You know, in our age of incredibly powerful and complex AI, we all kind of assume that bigger is always better. But what if that's not the whole story? Today, we're going to ask a really important question. When is a simpler, classic statistical model actually the smarter choice over a new AI giant?
So let's make this real with a super simple problem. Imagine you want to predict how many people are going to show up at the beach on a sunny day. Now, this sounds pretty straightforward, right? But it perfectly sets the stage for us to compare two very different ways of finding the answer.
So, here's what we're going to cover. We'll start with the classic, the GLM. Then we'll get into its secret weapon, something called the link function. After that, we'll introduce the modern powerhouse, the LLM. We'll put them head-to-head, glass box versus block box. And we'll finish up by looking at why simpler can sometimes be so much smarter.
Okay, first up, let's talk about our classic model, the Generalized Linear Model, or GLM. Now, this isn't just some other regression model. It's a really flexible and powerful framework that's been a total cornerstone of statistics for decades.
So what is a GLM, really? Well, at its heart, it's basically an upgrade to the simple linear regression you probably learned about in school. But see, that basic model has some really strict rules. The GLM, on the other hand, is built to handle all sorts of messy, real-world data. We're talking counts, probabilities, stuff that just doesn't fit into a neat little box.
Okay, so every GLM has three main ingredients. First, you pick a probability distribution that actually matches your data. Second, you've got the linear predictor. This is the familiar regression part. And third, you have the link function. This is the special sauce, the clever little bridge that connects the other two pieces together.
And this brings us to one of its absolute best features. A GLM is what we call a glass box model. It's totally transparent. You can look right inside and see exactly how each input affects the final prediction. There are no secrets here.
So, you might be wondering, how does it pull off this flexibility? Well, the magic is all in the link function. This is the key piece of the puzzle that lets a GLM adapt to all these different kinds of data.
For every type of data distribution, there's something called a canonical link function. Just think of it as the most natural default connection, the most mathematically straightforward bridge between your linear model and the average of your data. And when you use this default link, you get some really nice statistical properties.
This table really brings it to life. For just plain old linear data, the link is identity. Basically, nothing changes. But for count data, like our beach visitors, the canonical link is the log function. And for a simple yes or no outcome, like if someone decides to go to the beach at all, we use the logit function.
All right, let's bring this back to our beach problem. Since we're counting people, we'd use a Poisson GLM, and its canonical link is that log function, which gives us a model that looks like what you see here. Now, I know the equation might look a little scary, but what it tells us is actually incredibly simple and powerful.
And here is the absolute key insight. Because of that log link, the model's parameters, those coefficients, they don't represent additive effects. They represent multiplicative effects. So a 10-degree rise in temperature doesn't just add, say, 100 people to the beach. No, it might actually double the number of visitors. And that is a much more realistic way to think about how the world actually works.
All right, let's do a complete 180. We're going to jump from the elegant simplicity of the GLM to the modern behemoth of prediction, the large language model, or LLM.
I mean, these are the models you hear about constantly, like OpenAI's GPT series. They are just monumental neural networks trained on an unimaginable amount of text from the internet, and their ability to generate human-like text has totally changed the game for AI.
And their growth, it's just been explosive. Back in 2018, GPT-1 had 117 million parameters. Just 1 year later, GPT-2 jumped to 1.5 billion. Fast forward to 2023 with GPT-4, and we're talking about models so massive they can handle not just text, but images too. It's wild.
But, and this is a big but, all this incredible power comes with a trade-off. If a GLM is our glass box, an LLM is a black box. We can put data in, and we get amazing, sometimes shockingly accurate results out. But understanding how it got that answer, it's profoundly difficult.
And this brings us right to the heart of the matter, the central conflict between these two approaches. It really all boils down to one single fundamental trade-off: interpretability, the ability to understand what's going on inside. So let's just lay it out, side by side. On one hand, you have the GLM's glass box. It gives us coefficients we can actually interpret. It answers the question, why? Why did the prediction change when the temperature went up? On the other hand, you have the LLM's black box with its billions of parameters. It is fantastic at answering what's the right answer, but it really struggles to explain the why.
And look, this isn't some new problem. This exact issue was pointed out way back with the very first GPT model. The sheer scale just makes true interpretation a massive challenge. We get the answer, but we don't get the reasoning.
So where does that leave us? What's the big takeaway here? It's not about saying one model is better than the other. It's about recognizing that they are different tools built for completely different jobs.
So when should you reach for the GLM? Well, you use it when understanding the why is your #1 goal. When you absolutely need to explain the specific impact of each variable for a business decision or for a scientific insight, or maybe just to meet legal requirements that demand model transparency.
At the end of the day, the interpretability of a GLM isn't a limitation. It's a core feature. It's its superpower. In a world of incredibly powerful but murky AI, the clarity that a simpler model gives you isn't just nice to have. It's often priceless.
So I'll just leave you with this one final thought. As our AI tools get more and more capable of giving us the right answers, maybe the truly human skill, the one that becomes more valuable than ever, is our ability to ask and to understand why.